Welcome to Cybersecurity from Scratch, Episode 9, SQL Injection. First, let's talk about what relational databases are and what SQL is, and from there we can understand what a SQL injection attack is. From here, it's a two-step process from the red team perspective, where first you have to find a vulnerability, and then two, you actually have to exploit it. From there, we'll talk about, from the blue team side of things, how to write code securely and reduce or eliminate your risk of attack. I like to think of relational databases kind of like Excel because it's a pretty decent analogy. So with an Excel workbook, you open it up on your laptop and you have usually data organized into columns and rows where each row is sort of a unique grouping of data that falls into those different columns. And each column usually will have a data type, like if things are organized like shown on the screen where there's a username, a first name, a last name, a password, a date of birth. Then you'll have like a date object, which Excel will recognize in that date of birth field. There will be a string in the username, first name, last name, and password fields. And then each row is sort of like each user, John Doe, Gary Payne, and so on and so forth. Now then you'll have not just one sheet in each Excel workbook, you'll usually have multiple tabs that you can go to. And with a relational database, you have different tables. Like you'll have a table for users, you'll have a table for their schools, you'll have a table for their roles, and so on and so forth. And then, of course, you'll have multiple Excel files on your system. And this is kind of like the different databases where you can have different databases all together on the same server, just like you could have multiple Excel files. Now think, if you had to program a computer to pull stuff out of Excel, how would you go about doing that? No, the way that we do that for relational databases is by saying that we want a particular set of columns from particular tables where different conditions are met. So for example, if we wanted to pull out the ID element from the different users, we could say select ID from users, that ID column from the users table, where username equals ahackerson and password equals 12345. So the engine would go in and say, okay, I'm iterating down each row and I see if those two columns, username and password, are equal to the values that are set. And in this case, this is clearly some sort of authentication check. If the credentials are valid, an ID comes back, and if not, then the system says, nope, we don't have anything. Now, select is just the first option that you can have and the most simple for getting data out of a database, and the one that we're going to be looking at today for SQL injection vulnerabilities. However, there's other commands in the SQL language as well, such as update, insert into, delete from, and so forth. These are kind of complicated, so we're not going to get into it in this most basic episode. There are a lot of different relational databases that implement a SQL interface. However, some are more popular than others. One of the most popular is MySQL, which was then forked into MariaDB, which was basically maintained by some of the original developers. And if you're doing pen test training, you're going to see these databases pop up a lot. They're free, and they also have some interesting features which are kind of fun and interesting to exploit in pen test training and CTF exercises. Just for example, you can use the syntax load file and then give a file name, and it'll actually give you the contents of that file in your query. So say, for example, you found a way to do a SQL injection, and you're able to get this statement somewhere into the code. You're able to pull basically any file that the database has access to, which is, kind of a fun thing to do. And then it's also got some fun old exploits. So as you're learning about ways of using ExploitDB to sort of dredge up old exploits for older code, MySQL and MariaDB are a great place to look because they've got plenty to choose from. Microsoft SQL Server also pops up a lot in pen test training and capture the flag exercises, both because it's used a lot in the real world and there's some fun misconfigurations that can be exploited. Just for example, there's something called XP command shell, which allows the database server to run system commands. So a little bit of a metagaming thing with capture the flag. If you see someone using SQL Server instead of MySQL, that might be a good hint that the designer wants you to be using XP command shell and find a way into that. Of course, often that's not the case. Sometimes they're just picking it because they like it or if it's better with the sort of ecosystem that they've put together. But a lot of times it's an indicator that they might want you to sort of go in via that vector. At the most basic level, a SQL injection attack is taking the SQL syntax that we saw before for pulling information out of the database or putting data into it and interrupting the control flow in some way, basically changing fundamentally the structure of the query so that it does something that the original programmer did not intend, and it starts doing things that you want as the attacker. If you have a variation on the query that we looked at earlier, select ID from users where username equals blah 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 and password equals blah blah blah, if you're building this query on your web server, at least if you're building it in an insecure way, you might say my string query will equal that select ID from users where username equals, and then you'll have a single quote and then double quote terminate the string, do a plus and then your username, and then a plus and then a double quote to start a string again, have a single quote, and then go on with your and password equals, and then do sort of the same thing with your password at the end there. And so from the UI, the user basically has full control over what that username and password variables are that get dropped into the string. So you'd basically say select ID from users equals username equals Gary and password equals 12345 if that's what the user enters and is cooperating with you. However, the user might not cooperate. If they drop in a single quote in the username field, then you'd have a select ID from users where username equals single quote, single quote, single quote, and then suddenly SQL has no idea what's going on because they've just completely broken the syntax. So this is the most basic SQL injection where you've injected a SQL character into a string. It doesn't actually do anything productive, but it breaks the control flow and stops the programmer from doing what they wanted to. For now, we'll stick with this single quote technique to find SQL injection opportunities, where we'll use a single quote into a user-defined field and basically see what happens. Now, this is only available or useful as a means of attack in certain scenarios. If you have a totally blind SQL vulnerability, then that single quote isn't going to really do a whole lot for you. So say, for example, you have a username and password field that is vulnerable to SQL injection, and you drop in that single quote there. Now, the problem is that unless you get some sort of indication that there's a different error between the sort of not having a username and password validly versus I actually broke the SQL query and the database server doesn't know what to do with it, if the server doesn't tell you that there's a difference between those two things, you don't really know. You need something a little more sophisticated to find the vulnerability, but we'll get into that later. Now, in case you do have that sort of partial error, you can start working with that. You can say if there's a difference between an incorrect username and password versus an internal server error, you can say, I now know that I can break the SQL query, and from there start figuring out how to exploit it, but we'll get to that in a few charts. And then in a perfect world, you have a full SQL error message that tells you the exact syntax that it's trying to submit and all that great stuff. And that just makes the job of the attacker way easier. Fortunately, in the real world, most people are smart enough not to do this anymore, but it does still happen. So we have this query, select ID from users, where username equals blah, 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 and password equals blah, blah, blah. And we know that if we drop a single quote into the username field, we can interrupt and terminate the SQL query by basically disrupting the syntax. So what we want to do is we want to use that information to get a valid ID back from the select query. The way we're going to do this is introduce a statement that's always true, so that we don't need to have a correct username or even a correct password. We just have to drop this in, and the statement will always resolve as true and will return some ID back. So what we can do is we can drop in a single query, so the username equals single quote, and then we say or, and then 1 equals 1, and then that will be true. And so whenever the database engine goes to check if a row is valid, it will see that, well, 1 equals 1, so this ID is valid. But this doesn't get us all the way there, because then we're just getting back all the user IDs, and probably the code is going to be smart enough to say, you know, that's not really unique. Clearly something went wrong here, and it's not going to let us in past the authentication portal. So what we want to do is say a single quote or 1 equals 1, limit 1, saying that we just want a single entry, so to give us that first entry back that's available. And then, of course, we want to terminate our little injection with a semicolon to finish off the SQL statement. And then, assuming we're using MySQL, a hash sign, which will basically create a comment character. And then all of the remaining password equals blah, 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 all that good stuff just gets turned into a comment, and the database server ignores it. So basically, the full query ends up being select ID from users where username equals single quotes terminated, like single quote, so it just equals an empty string, or 1 equals 1, limit 1, semicolon, end of statement, comment tag, and then all the other stuff about password equals whatever, that just gets commented out and it doesn't even matter anymore. And so let's look at Hack the Box's magic challenge. So with this system, we go in, we've done our enumeration, we find a website just running on port 80, so an unencrypted website, and we see down here at the bottom this login. Please log in to upload images. Well, I guess uploading images is probably the way I get code execution. Wonder if there's some sort of file inclusion vulnerability there. So let's go ahead and log in, but we don't have passwords. So let's try SQL injection. So what we're going to do is just first do an admin, just to see what happens. Wrong username and password. Okay. Let's try that again. This time, let's try to make it barf with a SQL character there. And we can put whatever in the password field, doesn't really matter. Ooh, that's interesting. Doesn't give us the same error message. It comes back, but something's different this time. So we might be vulnerable. So let's try the basic injection that we saw before. Log in, bam, we're all set. That was easy. Whenever you're viewing a page that has, for example, a list of names or some sort of email list or really any kind of data that's being extracted from some sort of backend data store on the website, it's probably being drawn from a relational database, and it's probably using a select query. And so if you can find a way to hijack that select query, you really can pull out pretty much whatever you need. Of course, that's the tricky part. So say, for example, that you have a web page that shows first names, last names, and emails. It probably has a select query, something to the effect of select first name, select last name, select email from users where username equals, and then, whatever username was supplied, or it might not even have that where clause. It might just be, from users, and then you get everything from users. And if you were able to figure out what the syntax of that query was, and it did have a where clause that you could inject a value into, really that allows you to have an open door to anything. So basically what you're going to want to do is then use a union statement to dump your own select statement in there. Now, this is a multi-step process, so don't worry about this on the first go. We'll break it down for you step by step. But essentially what you're going to be able to do is terminate the single quote for the where clause and do a union to your own select, saying I want to select password from the admin table where the username equals admin or whatever it might be. And then that would give you a full query that basically has the initial select unioned with a select that has the password retrieval that you want. So there's a couple different steps that you need to do to get from point A to point Z there. So let's go break that down. So let's start from the beginning. So we have some sort of web form in front of us, and we know we can enter a username, and we know that it's vulnerable to SQL injection because when we put a single quote into it, it broke it in some way. We got some sort of different behavior than if we gave it some sort of other invalid input. So the first thing we need to do is figure out how many entries are in the select query that must be driving this page. So what we're going to do is test out with a union select null statement to figure out exactly what's going on. So when we try first with a single quote, union select null, semicolon, comment character, if that's not the right number of items, which in this case it isn't, we're going to get an error from the SQL database. which specifically will be a mismatch in the number of select values. Now, whether that manifests to you, the user, as an error telling you explicitly that, or if it's just some sort of different behavior, you can use that information to say that, we're still looking at an invalid SQL query. So then from there, we try adding a second null. So single quote union select null, comma null, semicolon, etc. And that is still going to give an error because the statement wants 3 values returned. And then finally, if we try union select null, 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 you're going to get a success, or at least you won't have an invalid SQL statement anymore, and it will be allowed to return. Now, next we're going to want to test out where in this statement we can return a string or a varchar so that we know where we can pull our passwords out. So in this case, if we say union select and then have some sort of test value string there, we'll see if that barfs and actually returns a correct value. And in this case, it's a simple statement that just has 3 varchars being returned, so that's nice and easy. But if you have a mix of varchars and integers and other stuff, it can be a little bit more tedious to sort of move that test value string through the query to figure out exactly where you are. So basically think of it as step 1, you have to figure out how many items are in the select statement. Step 2, you have to find at least one thing in the select statement that you can actually use to return the string values that you want. So now that we have an ability to get data out of the database, we have to take a step back and figure out where exactly in the database that information might be. And so the first step is asking the database server how many databases it has and what those database names are, so we can start then drilling down into those databases. So in the case of MySQL, the way to do this is to use a select schema underscore name from information underscore schema dot schemata. Now, this would give you a set of all the different schema names that are available. So in our union example, this would be a single quote union select schema underscore name, comma null from information underscore schema dot schemata, semicolon, and then the comment character. So from here, we'll have a set of the databases we can start pulling. Now that we have a list of database names, we also want a list of table names. So what we can do is select table underscore name from information schema dot tables, where table schema is not equal to MySQL and table schema is not equal to information schema. This is going to filter out some of the default tables that go with the MySQL database and the information schema management database, which sort of come bundled with MySQL by default. So altogether, that would be union select table name, comma null from information schema.tables, where table schema is not equal to MySQL and table schema is not equal to information schema. Next, now that we've identified a table that we want to look at, we can list the columns associated with that table. So what we can do is say select column name from information schema.columns, where table name equals whatever the table name is, and then that way we have a good dump of the columns associated with that table. Now finally, we can inject this combined statement together. We'll say that we have our single quote to terminate the username element of the where clause. We'll say union select password, comma null, from the admin table where username equals admin. And there, we have it. Now, a bit of a final caveat. Sometimes, even though the SQL query may be able to return multiple entries with the select statement, the actual server that's distributing the web content won't be able to use it. It's assuming that only a single record is coming back, in which case, if you give it multiple entries with a union statement, things might break. So the way to get around that is to use the limit 1, 1 syntax at the end of the return statement, which will force only a single entry to be returned. And then what you can do is increment the first 1 to 2 and then to 3 and so forth to return different entries. So you can think of it sort of as giving the SQL instruction the command to treat the return as a list, and then basically iterate one by one through the list. So if, for example, you're trying to iterate over the set of users, you could say select username from users, limit 1, 1, you'll get the first username. limit 2 comma 1 in the second query, and you'll get the second username, limit 3 comma 1 in the third, and you get the third username, and so on and so forth. And this will allow you to iteratively build up entries when you have only access to a single record return at a time. So let's take a look at the machine Jarvis on Hack the Box, because it has a great example of how we can enumerate a database. So we've been poking around the website that's available on port 80, and we've gotten to a page where we're looking at individual rooms at some sort of hotel booking site, and we can see this argument here, COD equals 1, and we can see that we're seeing an individual room here. So probably what's happening is there's a select statement that's taking that 1 and doing something with it on the back end. So let's test that theory out. Let's try breaking it by adding in a single quote. And it's still loading the page, but clearly something's breaking on the back end there. Like it's not able to actually load as expected. So that's a good start. So let's go a little bit further and do a union select 1. And then this dash dash is also a comment character here. So that's not going to work. All right, let's try it again. 2. Nope. This is another variation on the null test that I showed earlier, where instead of writing null, you can do single digits, where if the number is castable to whatever data type is expected, it'll work. So an integer will work if it's being cast into a varchar. So let's see, 5, nothing. We're all the way up to 6, nothing. Ah, well, there we go. We've got a perfectly valid query now. So excellent. So we've done our first step and figured out how many fields we need to do a select on in our union. So now that we know how many entries we can pull out, let's see if we can find a place to pull our strings. So I think that the first item here is probably some sort of identifier. So likely the second value here is going to be like a title or something like that that I can inject to. So I'm going to say, let's try test value. I also want to make sure that I'm not unioning with a valid a table entry, because the valid table entry will probably be the one that's displayed, since the backend database is probably only going to be feeding that first entry into the web server. So let's try putting this to 99. This is basically under the assumption that the table IDs, or rather the row IDs, are sequential, and that there aren't 99 entries in that particular table. So now I hit enter, and there I can see that test value right here is the title here, and there, now I can plop in whatever strings I need. Now I need to figure out what my databases are. So what I'm going to do is plop in my query here, an injection that will say I want the schema name from information schema.schemata. Now I have two options really. I can use the limit 1 syntax that I showed before, or because in this database I have the group concat option available, what this will essentially do is concatenate together into one single return all of the different entries in this column. And so instead of having to iterate slowly one by one, I can just say, give me all your schemata essentially. So if I hit enter, there, I can see I have database hotel, I can have the information schema, I have MySQL, both of which come by default with the database, and performance schema. So I'm going to dive deeper into this hotel database here, since that's probably where I'm going to see some stuff. So what I'm going to do now is try to pull out all of the tables associated with the hotel database. So what I'm going to do is get this, again, group concat all of the table names from information schema.tables, where the table schema is hotel. So basically all the table names that are in the hotel database, cram them all together into one string. There's only a database, or only a table called room in the hotel database, which means that my assumption is wrong. I'm not going to find credential information in there, and that's not very helpful. So I need to take a step back. The next place I want to check is the default MySQL database, which does have a user table. Now, even though this is a common database table, we're going to sort of look through it the old-fashioned way, just so that we can see the process. So what we're going to do is first wipe out this query and say, I want to look at all of the columns where table name is user, and from there we'll be able to figure out what the columns are called. Ooh, here we go, and user and password are right there, so that's convenient. Let's go look at those columns. So in order to get both the username and password out, I need to modify my query a little bit. So I know that right now I can pull some sort of string into the second position here, but I want another one to modify. So I can see the 3 here sits down as a dollar figure, so I probably can't put a string in there, but I might be able to do something about number 4 down there. So let's try. And we can see that test value is there. So I can be able to dunk username possibly into the second, password into the fourth, and then I've got username and password. So let's give that a shot. So what I'm going to do is put user and password. Set it backwards. I'm going to put user in field 2, password in field 4, and basically see what credentials we extract. And there we have DB admin and a nice hash. Now we'll talk about password cracking later, but basically once you have this hash, you can get the password, and that's your key to the system. There's a variant on the select query where we don't have access to the select response directly. However, if we do have access to the error message which the server generates, what we can do is deliberately cause a SQL error and then inject messages into it. So for example, sometimes the database server will support the convert operation, where it tries to convert some sort of field into another explicitly, and then if it fails, it'll tell you exactly why it didn't work. So for example, if you're trying to convert an integer into a string, you know, that's the kind of thing that works, but try to do it the other way around, it's going to have a problem. And so if you try to, say, convert the version number of the database, which is a string, then it won't work, and you'll see the version number of the database. So this can be used to essentially do all of the same enumeration as the traditional select enumeration that we saw previously. However, it's just done in this error message. Note that this is reliant on the full SQL error message being exposed, which is not necessarily a common situation. While this last injection worked well inside the browser, sometimes things are a little more complicated. Perhaps the injection is in a post, or perhaps a cookie needs to be modified. Sometimes it's just easier to use Burp Suite's repeater. Now let's talk about the defense. Fortunately, there are several tools at our disposal and ways for us to reduce or even eliminate the risk that we'll have a SQL injection vulnerability. As a defender, there are several lines of defense. The first of these is that immediate barrier between your systems and the users. So when the user is submitting inputs, make sure that those are sanitized. This is really true with all input everywhere all of the time, but especially true with any information that's being plugged in any way, shape, or form into your database. Make sure that you're using standard libraries to make sure that the data you're getting has been checked for any funny business. In the case of SQL, you know, there are several well-known things you can look for. For example, those single quotes that we're using as our base level technique in this exercise. Definitely don't write your own input sanitizer, use a proven one. Finally, don't make the mistake of trusting input that you gave the user to give back to you. Just for example, if you have a select box or a radio button or something like that in a web form, it's easy to assume that because you gave the user the input, you can trust the input that's coming back. However, as we've seen with Burp Suite over the last several episodes, it's fairly straightforward to go in and just change the form to return whatever information you want. So really, you even have to sanitize the inputs that you've given the user to send back to you from a set of available options. Also, sanitize your outputs. Let your user know that something went wrong, but they don't really need to know anything about how you talk to your own database or even that a database exists. If you're going to have a SQL injection vulnerability, let's make it a blind one. If you do have to write SQL in your web server, one of the best tools you have in your arsenal is the prepared statement. Essentially what a prepared statement does is it defines a set syntax for the SQL query and then locks in the structure in a way that the user can only drop in values into that statement. However, the statement itself cannot fundamentally change. You can't start joining statements together, etc. So let's take a look at a few examples, which are given in Java. Now, of course, we've seen the wrong way to do SQL queries in Java before, where you simply drop in a user-defined field between a pair of single quotes, and really the user can do whatever they want to at that point. A better way to do it is to create a prepared statement, where you'd say select owner ID from owners where name equals question mark, and that's just the full prepared statement. You generate a prepared statement object off of that, and then what you would do is tell the prepared statement, I want to set that first question mark equal to a string, and then pass it in a value. Now, the prepared statement can only have the particular syntax that it has, a select statement with a single where clause with a single name equals something. So the attacker can't just drop in, whatever arbitrary thing. The structure there is fixed. And so there really isn't the same opportunity for abuse that you get with the previous just dropping in a random variable technique. And then you execute the query and things go on as normal from there. In a perfect world, you're not writing SQL at all. You're using a language or framework that allows you to query a database entirely without SQL using an API or something like that. For example, Ruby on Rails uses Active Record. So there's just no opportunity for the programmer to mess up and create a SQL injection vulnerability. Even with a prepared statement, there's ways to write the statement poorly or something like that in a way that could allow the attacker to do something bad. But when you have something so simple as user.findByName and then you pass in a string, there's really no way for that to go horribly wrong. Obviously, you still have a bug in the framework that you're using. That's possible, but the particular vector of writing SQL poorly just isn't a thing anymore. In our next episode, we'll talk about SQL injection with SQL map. This is an automated way of discovering SQL injection. Now, I'm showing this after I've shown the manual technique, because if you're studying for the OSCP, you really can't use SQL map, and you have to learn it the hard way. Trust me, I got my OSCP, and I would not have gotten my OSCP if I couldn't do this the hard way. And if you're looking for that certification, you're going to be in the same boat.